Here's an example of the square root function. X is assigned the value 9, so sqrt of x returns the value 3. Functions in R have names just like variables. So to use a function, you type the name of the function and then parentheses with the arguments to the function in the parentheses. Those arguments are any input that you want to give the function. So in this simple example, the name of the function is sqrt. That could be any arbitrary name, but in this case, sqrt happens to be the name that the default packages in R give to a function that calculates square roots. Then the open parenthesis initializes the arguments that I'm going to provide to the function that is the input to the function. In this case, just one argument, which is the variable name x, already containing the number 9, and then the close parenthesis to indicate that the function call is over. I'm done executing or done providing the instruction to execute the square root function. And the overall result of instructing R to carry out sqrt of x is that it returns 3. In this case, its return value is printed to the console because I called it directly. And so I see the number 3 because I calculated the square root of 9, which is 3. All functions are going to be like this. This is just a very simple example to get you started, that they will have a name and then parentheses, and in the parentheses, any arguments that are necessary in order to call the function properly. We'll have lots of more complex examples of functions in a little bit, but for the moment, cautionary note about names of objects in R. It is useful to pay attention to what names of objects are already in use in your R session so that you don't name things, you don't accidentally replace existing things that you have already assigned that you wanted to keep track of, or accidentally create multiple objects with the same name. In other words, pay attention so that you don't name your new variables the same thing as existing functions. So if you aren't sure if a name is already in use, you can always try typing it by itself at the console to see what, if anything, it currently represents. So if I wanted to say store the square root of x as a separate variable called square root, I might first try sqrt to see if I can use that as the name of my new variable. But I would prefer not to, because I've checked out sqrt and I see that it is already the name of something. It's the name of a function that takes an argument x and returns a square root of that value. It just calls a more primitive function in this case, but you'll see examples of functions where you can see more details about them by typing their name at the console. The point is, I did not get an error message telling me that sqrt was not found and a name available for assigning a new value. So I'm not going to use it to store the square root of x. Another option I have is the whole word square root. And that object is not found, which means that there is nothing by that name currently. So that is an error message that makes me happy in this case, because that means I can use this name for some new purpose. So I'm going to use it to store the square root of x, which should be 3. And it is. And now that 3 is stored with this new name square root. In R, quotation marks are used to denote string variables. So far, I've shown you examples of names of objects in R that refer to numeric values and that refer to functions like sqrt. So x contains a numeric value, 9, and sqrt contains a function. Your variables can also contain other kinds of data besides numbers. And the simplest example is a string. Quotation marks are used to denote strings in R. So if I assign the value x the value ASDF contained in double quotation marks like this, then x contains that string. ASDF is a series of 4 letters represented 4 characters, and we call that a string. And the quotation marks just are informing you that that's the beginning and the end of the string. I can also use single quotation marks to assign this value to x. So if I do x equals single quote ABCD single quote, then x contains the value ABCD. R provided printed the value of x to the console using double quotes, but the single quotes are a perfectly acceptable way to specify a string value. And that could come in handy if you want your string to contain the other kind of quotation mark. Oftentimes, the variable types that we'll be working with in R will be vectors. Vectors are very useful in statistical computing because we typically want to deal with whole columns of data with many observations in them, rather than just one number at a time, like x being equal to something like 9 or ASDF. Here, I'm using the C function to create the first example of a vector. The C function stands for concatenate. It creates a vector, an ordered set of data points out of discrete values supplied as arguments. So I called this function C. C is a very short name of a function, but it is just the name of a function like sqrt. And the parentheses indicated that I was beginning to supply the input to the function, the arguments. There are 3 arguments separated by commas. Function arguments are always separated by commas in R. And the 3 arguments are 2, 4, and 6, just numbers. So now x is a vector of the numbers 2, 4, and 6. A vector always contains elements of the same type, and so that's what a vector is by definition in R, is it's an ordered set of values of the same type. In this case, a numeric vector that has length 3. It has 3 numbers in it, 2, 4, and 6 in that order. If I wanted to retrieve just one value from a vector, I can use square brackets to subset it, to retrieve an individual value in this case. So x square bracket 1 will return 2, the number 2, because that's the first value in x. The square brackets contain the position of the value that I want to retrieve. X square bracket 2 would show me the value 4, because that is the second value in x. I'm going to create a longer example of a vector now. Now I'm going to assign x this new value, which is a longer vector also created using the concatenate function C. And this one is just 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21. I can use this to retrieve the first 5 values of x, 1, 3, 5, 7, and 9. What I've done is I have issued the command to R that it should tell me what x is, but then the square brackets indicate that I'm going to subset that. I don't want to see all of x, just some of it. And within the square brackets, previously I supplied a single number indicating what index I wanted to retrieve, but here 1:5 tells it that I want elements 1 through 5 of x. And the reason that works is that the colon itself is an operator that creates its own vector of numbers. 1:5 returns the vector 1, 2, 3, 4, 5. It's the integers from 1 through 5. The colon is just a shorthand for generating that vector. So 1:5, if I print that to the console, I see 1, 2, 3, 4, 5, and that's the same as if I called the concatenate function with 1, 2, 3, 4, and 5 as its arguments. So when I supplied 1:5 within the square brackets to retrieve those values of x, it just provided the 5 positions of the values that I wanted to retrieve from x in the form of a vector. 1:5 listed the individual positions 1, 2, 3, 4, 5, so I got 1, 3, 5, 7, 9, which is the first element of x, and then the second element of x, and then the third, fourth, and fifth. Arithmetic functions in R typically are applied to vectors element by element. Examples of these sorts of functions include the plus sign, the asterisk for multiplication, the slash for division, the minus sign, and the square root function that we've already learned about a little bit. So in this case, x is the odd numbers from 1 through 21. And if I execute the command x plus 1, then I see a vector that begins 2, 4, 6, and so on, 22. This is the result of adding 1 to each element of x. X times 2 will be 2, 6, 10, 14, and so forth, which is the result of multiplying each element of x by 2. I can also do things like log of x. Log is just another function like sqrt for square root, and this computes the log base e, the natural log of all of the elements in x. So the log of 1 is 0, and so forth.